Okay, children, let's try this again. You don't realize I'm trying it again, but I am. Because I screwed up this the first time, so I gotta do some of this again. Anyhow, pardon me. Here we go. Quiz 7, Chapter 5, Lessons 5, 6, and 7. First part is, and on this we're going to write everything on paper first, then we'll go back into the Google Classroom, and then enter all your answers at once you're finished. So what is your name? Who is your math teacher? Now, I know you could bubble in Mr. Houston, but if you really want to put who your favorite teacher is off to the side, you could do that if you really wanted to do so, you know. So anyhow, let's get started here. Let's look at number 1. We're talking about this picture over here. Up in the upper right-hand corner, that is a letter D as in donkey. So the directions simply are reading. Let's change the arrow up here. Let's go with blue. Why not? Now it says, we're going to use this image above. Which postulate or theorem can you use to show that the images are congruent? Okay. One thing you want to keep in mind is you got a couple of angles here and here and here. But what I would also do is these triangles overlap. I would redraw them and relabel them. Okay, and look for who is going to be used in both. That'll help you maybe find a side. All right, now I'm going to flip to the next. Your choices are right here. You got side, 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 side angle, side, or angle, side angle, side angle, side, angle, angle, side, hypotenuse leg, or CP, CTC. All right, if it helps, you could write this. You could go, just write the abbreviations off to the side like this. So these are your choices. C, P, C, T, C. All right. Number 2. Again, take your time, pause as you need. We're going to look at this, again, this picture over here. Okay. We want to find the length of DC. DC, right here. How long is this section? I'm kind of coloring in a little bit there for you. How long is that piece right there? That is just an open answer. When you type this into the Google, you just type the number. Okay. Directions say for 3 and 4, we got to refer to the image. Now this is on page. A lot of pages, but not that many questions. So let's flip over. We're looking, here's for 3 and 4. We want it says using the image above, find the length of ML. So that's from here to here. How long is ML? Okay. And then number 4. Let's zoom this out just a hair so we can see it all. We will find the length of JK, and I'm not JKing you. You need to find the length of J to K. So that's going to be all the way down to there. How long is that? Number 5, again, we're going to look at the image on the next page. So here's for number 5. We want to find the length of AB. A to B. Now notice you're given what part of this is algebraically, and you know what this other side is. That looks like a 7 right here. I'd set those two equal to one another, given the fact that this is going to bisect this one. All right, since these two sides are the same, these two sides are going to be equal. So just set up an equation where those two sides are equal to one another. Solve for x. Once you solve for x, though, plug him in and find the actual length of that side AB. Number 6, we're looking at this picture right here. All right, wants to know how many lines of symmetry does it have? How many lines of symmetry? Remember, if you draw a line, okay, you draw a line and say like that, and you folded both sides, it'd be the same on both sides. All right, so how many lines could you draw like that in number 6? Moving on to number 7. And we do also apologize that, as you can see, like this is the end of the question in number 6 on the previous page. This program, it kind of cuts things off, but you'll figure it out. You're smart. Number 7, says we're looking at this stop sign looking picture right here. Now, it wants to know how many lines of symmetry does this one have. So how many lines can you draw through from vertex to vertex? Whoops, I didn't do a very good job there. How many lines could you draw, like a line from here to there? If you folded that, would that be a line of symmetry? Would you have the same thing on both sides? In this case, you wouldn't, but I didn't want to give you the answer. So how many lines do you have total? There's the picture for number 8. Okay, and we're going to move on. Again, number 8 wants to know, using that picture, how many lines of symmetry do you have? So you could flip back and look at that triangle to see how many lines of symmetry you have. Number 9. Number 9 asks, is this image above up here, is this a reflection over line M? Is this being reflected? And you just put yes or no. Number 10, we're page. Again, wanting to know, is this image a reflection being reflected over this line? Yes or no. For 11 through 15, we've got a proof. Okay, a little challenging to see, but we can zoom in. But I want to go over this first, in that your answers are going to be the same. The choices are the same on every question. So, for example, question 11 is referring to this statement here. Well, that's kind of hard to see. Let's go back here. Let's try red. This is for question 11. That's 12, 13, 14, and 15. So that's your answers, okay? We're giving you choices. Make sure you pay close attention to the given information up here, all right? And then on your paper, it should be nice and clear, all right? Take a look at this picture over here. Notice we have 2 triangles that are side by side. I see a couple right angles there. I said something in class the other day about if you see right angles, should make you start thinking about something. Okay, so number 11, actually I'm just going to kind of leave it here for a second, okay? What is the statement? And number 1 there for 11. And like I said, I showed you where's this 12, 13. Okay, this is given information. You should know where to find given information. Number 2 says, the statement is triangle BAD and triangle CAD are right triangles. How do you know they're right triangles? You're going to write that reason right there. AD is congruent to AD. Well, for the same thing, what property, we've talked about this a lot, do we put right there? For the reason was angle bisector theorem. So if you look at the picture, who is the angle bisector over here? Okay, probably going to be a segment. So who is that segment? That's what you're going to put right here. And then lastly, triangle BAD is congruent to triangle CAD. So it's going to be one of our famous postulates. And again, your choices for all these are, of all these answers, 11 through 15, is it hypotenuse leg? Is it given information? Is it ray AD bisects angle BAC? Is it DB is congruent with DC? Or, off, the last one's on. Yeah, here it is. The reflexive property. But notice how they're the same on all of them, okay? And then the number 15 on the next page is still the same. It's the same exact answers. You're just going to be marking a different one. You're going to use each one of these just one time, okay? And that's it for the quiz. All right. So take your time, do all your work on the paper, write your name on the paper, and make sure then we'll go back into the Google Classroom to put your answers into the program. Okay. So I hope you have a great rest of the day. Adios.